Myself, M. Karthik Kumar Reddy, working as an assistant professor in Nalla Narasimha Reddy Education Society's group of institutions in the Department of Civil Engineering in Foundation Engineering subject. I am going to explain about Unit 5 Pile Foundations. Now, the type of the piles depending on its function, its method, construction, they have been divided into various categories because we have seen just now that how these piles they are being as far as the load transferring mechanism is concerned. You have seen that if the load is getting transferred through end bearing, if it is through friction, if the load is transferred through end bearing, it is called as end bearing pile. If the load is transferred through friction, it is called as friction pile. Then laterally loaded piles, anchor pile, tension pile, compaction pile, etc. So here, based on the material of construction, you have timber piles, steel piles, concrete piles and composite piles. However, in case of cross section piles, steel piles, concrete piles and composite piles. However, in case of cross section of the piles can be circular, it can be square, it can be hexagonal, I section or a H. So depending upon the cross section, you can call if the cross section of the pile is circular, it will be known as circular pile, square pile, depending upon the type. Now based upon the shape, it can be cylindrical tapered or under rimmed. That is, under rimmed pile foundation may also exist. We will be discussing a little in detail, maybe in subsequent slides. Then how it is formed, that is whether it is already precast at some other location and then transferred to the site, or whether it has to be installed, or it may happen that it is getting casted at the site. That is, you see here cast in situ. This means that pile is being casted at the site only. It has not been precasted and transferred to the site. It is getting casted. Then method of installation, that is pile can be driven, it can be bored or it can be done. So depending upon this method of installation, there are various types of piles. Now it has been realized that perhaps the best way of classifying the pile is on, there are two classifications of piles. One is displacement pile. During the installation of the pile, a large volume of the soil is displaced laterally and upwards. So let us say that during the construction or during the installation of pile, if the method adopted is such that a large volume of soil is displaced laterally or upwards, then those piles are called displacement piles. In case of non-displacement piles, in their installation procedure, there is no displacement of the soil at all. That means that there is no displacement of the soil remaining as it. Now let us try to see some of the aspects related to the displacement piles. So in the distance of about 3.5 meters, the diameter of the pile measured from the center of the pile. You see what happens is that when you, as I explained you, that in case of loose sand strata which is present over there, if you drive a pile, sometimes it may serve the purpose of compacting. So usually when a pile is getting driven into the sand strata, let us say one pile is getting driven, what happens is this: if the diameter of the pile is 1 meter, then around that, so if 1 meter is the diameter, so around 3.5 meter distance around the pile will get densified, whatever sand is there in that particular area. So this compaction leads to an increase in the angle of shearing resistance. So what is the zone of influence here in this case is 3.5 times the diameter of the pile. Obviously, when the loose sand is getting compacted, it will be increasing in the shear strength parameter. It is the strength will decrease, and so it is the shear parameters. Now what happens in clay is that in clays larger displacement piles remove the soil, so that it was in the case of loose sand, that is cohesionless material. In that one, the extent of influence zone was 3.5 times the diameter of the pile. However, in case of clay, that is 2 times the diameter of the pile. Now during driving, very high pore water pressure are set up around the pile. Very high pore water pressure are set up around the pile, and the soil regain its initial strength only after a period of time. When the excess pore water pressure are dissipated, then mostly the phenomenon is the consolidation. What is meant by consolidation is that the dissipation of the pore water pressure with time. So this, when if during driving very high pore water pressure are set up around the pile, so the soil will regain its strength after some time. When that extra pore water pressure, when that extra pore water pressure gets dissipated, after that only these are preferred for use in loose to medium sands. That means the displacement piles there are preferably used in loose to medium sands, because in case of dense sand, what will happen is that it will become very difficult to drive these piles, because they have the tendency to compact the soil about 3.5 times the diameter of the pile. However, in case of clay, what will happen is it removes the clay about 2 times the diameter of the pile. So in with that the high pore water pressure gets generated, so in the soil loses its strength. That is why it is not preferable in case of dense sand or the various types of what are the various types of large displacement piles. They are driven in cast in situ, driven precast or pre-stressed concrete piles, timber piles, etc. These are various examples. Now if you see the driven, what do we mean by a driven term? The driven is that you are driving, so there are two methods. Simply the pile is constructed, already you are driving it with some mechanical hammering or some vibration technique, so the term is known as driven. Then cast in situ, as I explained you, it is getting casted in the field itself. Then driven precast, it has been casted already, transferred to the site, and then getting driven by some mechanical hammering process. Pre-stressed concrete pile in there is that one, the pile gets stressed during its construction, that is when it is getting precasted or when it is getting casted, then there is some stress which is being inbuilt, which is forced to inbuilt in the pile. That is what is pre-stressed concrete pile. And then the timber pile, you know, if it is made of timber, that is timber pile. Now displacement piles, again there are some piles like the rolled steel section piles, screw piles, open-ended hollow section piles, etc., which are classified as small displacement piles as an account of their small cross section. They produce small displacement of piles. So you see, in case of rolled steel section, screw piles, etc., what happens is, since their cross section is small, they produce very small displacement of the soil which is around. That is why they are called the small displacement piles. The small displacement piles are preferred when ground displacements and disturbances are to be minimized. Now when this condition can occur, let us try to say, wherever is your construction site, some nearby structure is very sophisticated one, and you really cannot allow that soil to be so in that case, and at the same time you cannot go for shallow foundation. So those type of locations you need to go for this small displacement. So now let us try to see some of the features of non-displacement piles, how they are. A void is formed in the soil by boring or excavation and is then filled with concrete, happening that while driving or while installing the pile, the disturbance was caused in the surrounding soil also. That particular type of, however, in case of non-displacement piles, what happens is that a boring is done or some excavation kind of thing is done, and then concrete is poured into that particular void which is created by boring or excavation, and it is filled with concrete to form the pile. The sides of the void can be unsupported or supported, either permanently by casing or temporarily by casing or drilling mud. Now the thing is that, let us say that you have to go, obviously whether you are going for pile foundation, the soil strata is going to pour. Now if the length of the pile, say it is of the order of 25 to 30 meters, sometimes it becomes difficult to make that particular bore or that particular borehole exactly in a vertical direction. It may happen that the voids of that particular borehole may get collapsed. So in that case, how we can support them either permanently or temporarily. So permanently casing can be used to support that particular borehole, or temporarily by casing or drilling mud and bored precast piles. Now here I am introducing this new term as bored. Earlier it was, so the method of installation was with the help of some mechanical measure, that is by hammering or due to vibration. But in case of board, it was first the void is getting created, which is usually called as borehole, and then when the concrete is being, so in that case it is getting casted on the side itself, so that becomes board cast in situ pile. However, if the void is being formed due to the boring or excavation, and in that during the installation of this non-displacement pile, the soil on the sides of the borehole softens due to the contact with wet concrete or due to water used in the borehole to facilitate boring. This results into loosening of soil if it is clay type, loss in shear strength and reduced pile bearing capacity, and if it happens to be sand or gravel, then it is difficulty of concreting under water and likelihood of wasting or necking of concrete in squeezing. In the non-displacement piles, pulp ends cannot be made in granular soils. It is essential that concrete is placed as soon as possible after the boring is done to minimize the softening of soil.